Hello friends, how are you? In this video, we'll discuss about fuzzy implication. So first of all, we should know what is implication. So what is implication? So implication means the conclusion that can be drawn from something. So we have something and we can draw some conclusion. So that is called implication. Okay. So what is fuzzy implication? So fuzzy if-then rule or fuzzy condition statements or fuzzy implication follows the form. So here we can apply something fuzzy implication like this way. So it is also called fuzzy if-then rule. It is also called fuzzy rule, or it is also called fuzzy conditional statement, or it is also called fuzzy implication. So all are same thing. So fuzzy implication or fuzzy if-then rules, both are same. So fuzzy implication is like that. So if X is P, then Y is Q. Okay. So we have a something and we conclude something. So that is possible using the fuzzy implication. Okay. So here X is P, it is called antecedent or premise, and Y is Q, it is called consequence or conclusion. So here P and Q are two linguistic variables. P and Q are the linguistic variables defined by fuzzy sets X and Y, capital X and capital Y, on the universe of discourse capital A and capital B respectively. And here small x and small I, these are called the generic values. So you can see some example. So if temperature is high, then pressure is low. So it is a fuzzy implication. Okay, fuzzy if-then rules or fuzzy rule. So here high and low, these are the linguistic variables, and temperature and pressure, these are the generic variables. Similarly, if mango is yellow, then it is sweet, else it is sour. So yellow, sweet, sour, these are what? Linguistic variables. Mango, it is nothing but our generic variable. Similarly, if study is good, then knowledge is high, else knowledge is low. So study, knowledge, these are the generic variables. Good, high, low, these are called the linguistic variables. So in this way, we can represent the fuzzy implication or fuzzy if-then rule or fuzzy rule. Now we can see notations. We use two notations to represent all these things. Say R is nothing but our fuzzy implication. We denote like this way, and A arrow B. So notation to denote the fuzzy implication. So to denote the fuzzy implication, we write like this way: A arrow B. So it is interpreted by two ways: A coupled with B or A entails B. And we have another notation, that is A cross B. So it is a binary fuzzy relation R on the Cartesian product of A and B. Okay. So already we have discussed that there are two ways to interpret the fuzzy rule. Okay. So it is what? Fuzzy implication or fuzzy if-then rule. So is A coupled with B or A entails B. So we can represent like this way. Say we can see here. So it is what? Fuzzy implication, A coupled with B. So A arrow B. So to get this membership values, we may represent like this way: summation X cross Y, inverse of discourse, and we had here these two are the membership values of fuzzy set A and fuzzy set B, and this cross is nothing but the T-norm operator. Okay, so we will see all the T-norm operator. So the most popular T-norm operators are minimum, algebraic product, bounded product, and drastic product. So if we apply minimum, then we have to take the minimum value in between these two. If it is algebraic product, we have to multiply these two values, membership values. If it is a bounded product, we have to get the maximum in between 0 and addition of these two membership value -1. And if it is a drastic product, so then the T-norm operator is what? If mu bx is 1, then we have to take the mu ax. If mu ax is equal to 1, then we have to take mu bx. And if mu ax and mu bx both less than 1, then you have to take the membership value 0. So the important is the fuzzy rule can be defined like this way, as a fuzzy set with two-dimensional membership function. Okay. So here mu r x comma y. So here we can apply this particular the fuzzy implication function. Okay. So to get the fuzzy implication function, definitely we can apply the T-norm operator. Okay, we can apply T-norm operator, and already have discussed all the T-norm operator. So to get the membership values, we may use the operator as follows. So definitely we may apply mean operator, algebraic product operator, bounded product operator, and drastic product operator. All these are the trinom operators, and we can get the fuzzy implication function values of these fuzzy membership values. We have to apply these particular trinom operators. Moreover, there are different ways to interpret such implication. So say first one is called material implication. So here to get the membership value, we may apply max in between 1 minus mu x comma mu by. Okay. Similarly, propositional calculus, we may apply like this way. So max in between 1 minus mu x comma minimum in between mu ax and mu by. Okay. Similarly, extended propositional calculus, so here we may apply max in between minimum 1 comma mu x comma 1 minus mu b comma y comma mu b. So you have to take minimum in between these two and maximum in between the result of this and this. Jadis arithmetic rule. So here you have to apply minimum in between 1 comma 1 minus mu x plus mu by. And Jadis max min rule. Here you have to apply max in between max value in between 1 minus mu x comma the resultant of these two. Here you have to take the minimum in between these two. Similarly, Boolean fuzzy rule. So here we can get maximum in between 1 minus mu x comma mu by. And you can apply Gauguin's fuzzy rule. So here if mu x less than equal to mu by, then the value should be 1. Other if mu x greater than mu by, then the membership value is what? Mu by mu x. Now the implication in if then rule statement. If the fuzzy rule is what? If x is a, then y is b. Here a and b are what? Fuzzy linguistic variable, and x and y are what? These are the generic variable. Then the membership values or the representation of this particular rule, we can represent this particular rule like this way. So rule R is equal to what? A cross B union not A cross Y. So membership function of R will be what? We have to take max min composition. So max minimum in between mu x mu y, and we have to take max in between the answer of this comma 1 comma mu x, and you can get the membership value. So we will see one example. So for compound implication, say another rule is there. If the rule statement is like that, if x is a, then y is b, else y is c. Okay, so in that case, the relation R is equivalent to this one. So R is equal to A cross B union A cross C. So here not A cross C. So the membership function of R is given by like this way. So minimum in between mu x and mu by, and minimum in between 1 minus mu a comma mu c by, and we have to take the maximum value in between these two to get the membership value of the fuzzy implication. So we can see one simple example. Say capital X and capital Y. So capital X contains x1, x2, x3, x4 inverse of discourse. Capital Y contains A, B, C, D. 3 fuzzy sets are there. It is also called the linguistic variable P, Q, S. These are the fuzzy sets as well as linguistic variable. So here elements are x1, x2, x3, x4. A contains, Q contains A, B, C, D. S contains A, B, C, D. And 0.3, 0.6, 0.9, 0, 1, 0.8, 1, 0. These are the membership values. Okay, so X, x1, x2, x3, x4 and A, B, C, D. These are the generic variables. So determine the implication relation. So if X is P, then Y is Q. Second is what? If X is P, then Y is Q, else Y is S. So how to get this one? So definitely solution number 1. So if X is P, then Y is Q. So we can represent relation like this way. So R is equal to P cross Q union not P cross Y. So first of all, we just see the solution one by one. And so first of all, we have to apply this particular cross operation. So P cross Q. So P linguistic variable of fuzzy set, the element over what? x1, x2, x3, x4, 0.3, 0.6, 0.90. You can see x1, x2, x3, x4, 0.3, 0.6, 0.90. And Q is what? A, B, C, D. Okay, 1.8, 0.10, 1.8, 0.10. So first of all, to get this one, we have to apply the cross in between P and Q. So definitely already we know how to get this one. So we have to compare x1 with ABCD, x1 with ABCD. So it is 0.3 and 1. So minimum is what? 0.3, 0.3 and 0.8. Minimum 0.3, 0.3 and 0.1. Minimum is 0.1, 0.3 and 0. Minimum is 0. Similarly, x2 with ABCD, 0.6 and 1. Minimum 0.6, 0.6 and 0.8. Minimum 0.6, 0.6 and 0.1. Minimum 0.1, 0.6 and 0. Minimum 0. Similarly, x3 with ABCD, okay, so 0.9, 1, minimum 0.9, 0.9, 0.8, minimum 0.8, 0.9, 0.1, minimum 0.1 and so on. So in this way you can get P cross U. Similarly, to get not P and Y, okay, so to get not P and Y, so where Y is the universe of discourse, that is for all the elements A, B, C, D, the membership value should be 1. That means Y is what? Y is a fuzzy set, it's a universal set. So A, B, C, D all are contained, Y must contain A, B, C, D. That's why the membership values are what? 1, 1, 1, 1. And here we have to apply not P. So P already you know. Okay, so P is what? x1, x2, x3, x2, 0.3, 0.6, 0.9 and 0. So not P is what? 1 minus 0.3, 0.7, 1 minus 0.6, 0.4, 1 minus 0.29, 0.1, 1 minus 0, it is 1. And the elements are what? x1, x2, x3, x4. Same as that, x1, x2, x3, x4. So x1, x2, x3, x4, x1, x2, x3, x4. Not P is what? 1 minus the membership values of the element. So 1 minus 0.3, it is 1 minus 0.3 is what? 1.7. And then what we have to apply? We have to apply the cross. So we have to apply cross in between. Okay. So we have to compare x1 with A, B, C, D. Here all are 1. So definitely here you have to select the data from this particular set only, because always the membership value should be 1. Here the membership values of A, B, C, D are what? Always it is 1. So definitely we have to take the minimum in between these two. So definitely we have to select the value from this, because this value should be minimum with respect to this. So 0.7, if you compare 0.7 with 1, 1, 1, definitely always you have to take 0.7. x2 is 0.4, you have to compare with 1, 1, 1, definitely you have to take 0.4. 0.1, if you compare with all this 1, 1, 1, definitely you have to take 0.1. And x4 is 1, so if you compare with 1, 1, 1, definitely it should be 1. So this is nothing but our not P cross Y. Then we have to apply the union. So to get union, we have to apply the max part. So to get max products, we have to compare this value. So 0.3 and 0.7, maximum is what? 0.7, 0.3, 0.7, maximum 0.7, 0.1, 0.7, maximum 0.7, 0.7, maximum 0.7. Similarly, 0.6, 0.4, maximum 0.6, 0.6, 0.4, maximum 0.6, 0.1, 0.4, maximum 0.4, 0.4, maximum 0.4. Okay, 0.9, 0.1, maximum 0.9, 0.8, 0.1, maximum 0.8, 0.1, 0.1, maximum 0.1, 0.1, maximum 0.1. So here all 0 are there, here all 1 were there. Definitely you have to take the maximum value. That's why all the elements of the last row should be what? 1, 1, 1. So this is nothing but our representation of if x is P, then Y is Q. So that is the implication relation of the first one. If x is P, then Y is Q. Finally, second problem, if x is P, then Y is Q, else Y is S. So here we have to apply this particular formula, P cross Q union not P cross S. So the membership value is what? First of all, you have to apply the P cross Q. So to get P cross Q, you have to apply this particular formula. So minimum we have to minimum value in between these two membership value. And then is what? It is not P cross S. To get this one, we have to apply this particular not P means what? 1 minus mu Px. And S is what? Membership value of S. We have to take the minimum in between. And definitely union is there. Definitely we have to take the max value. Okay. So P cross Q, just we have completed, just we have seen. Okay, you can see here. So P cross Q is what? This is what our P cross Q, just we have seen. Okay. And not P crosses. So P is what? P contains 0.3, 0.6, 0.9 and 0. Not P contains 1 minus 0.3, that is 0.7, 1 minus 0.6, it is 0.4, 1 minus 0.9, it is 0.1, and 1 minus 0, it is 1. And not P crosses means what? We have to compare these two and we have to take the minimum. So x1 with A, B, C, D. So x1 with A, B, C, D. So 0.2, 0.7, minimum 0.2, 0.7, 0.5, minimum 0.5, 0.7, 0.7, minimum 0.7, 0.71, minimum 0.7. Similarly, x2 with A, B, C, D. So 0.4, 0.2, minimum 0.2, 0.4, 0.5, minimum 0.4, 0.4, 0.7, minimum 0.4, 0.41, minimum 0.4. x3 with A, B, C, D. 0.1 with 0.2, minimum 0.1, 0.1 with 0.5, minimum 0.1, 0.1 with 0.7, minimum 0.1, 0.11, minimum 0.1. Similarly, x4 with A, B, C, D. So x4 with A, B, C, D. 0.1 and 0.2, minimum 0.2, 1.5, minimum 0.5, 1.7, minimum 0.7, 1, minimum 1. And then we have to apply the union. So we have to apply to calculate a match of this. So if you compare 0.3, 0.2, minimum, maximum 0.3, 0.3, 0.5, maximum 0.5, 0.1, 0.7, maximum 0.7, 0.7, maximum 0.7. Similarly, 0.6, 0.2, maximum 0.6, 0.6, 0.4, maximum 0.6, 0.1, 0.4, maximum 0.4, 0.4, maximum 0.4, 0.9, 0.1. So all are 0.1, here 0.9, 0.8, 0.1. So also to the 0.9, 0.8 and 0.1, here 0 and 0.1, maximum what? 0.1. Similarly, here all 0. So definitely we have to select the data from this side, 0.2, 0.5, 0.71, 0.2, 0.5, 0.71. So this is what this R represent. If X is P, then Y is Q, else Y is S. Okay, and that is the end of this particular video. Thank you very much.